Well, dear students, good morning. It is very cold here today. Uh, I have the topic here: optoelectronic junction devices. Till now, I discussed in last videos PN junction, its working, and there I defined so many things like potential barrier, depletion region, junction field, and before that I explained you photoconductivity. If you remember, photoconductivity, the conductivity shown by a semiconductor when it is exposed to light. Actually, when we know that energy of photons of visible light varies from 1.8 electron volt to 3 electron volt, red to violet, nearly 3.01 electron volt. And energy gap between valence band and conduction band is less than 3 electron volt in general. For silicon it is 1.1 electron volt. So if light photons are absorbed by a semiconductor, then those photons energy will be gained by electron, and in semiconductors majority of electrons are present in valence band, means their energy is lower than energy which they need for conduction. And by absorbing energy of photon falling on semiconductor, electron can go to conduction band, thereby number of electrons in conduction band and holes in valence band increases. This increased number of electrons and hole in conduction band and valence band increase the conductivity, and that is called photoconductivity. So these optoelectronic junction devices are simply PN junctions having special purpose, and their working is based on photoconductivity. So first PN optoelectronic junction I will discuss here is photodiode. Photodiode, or its name also called as photodetector. Photodetector. Detect means to sense or to find. So photodiode, photodiode is special purpose PN junction. PN junction diode, which is fabricated or constructed. In place of fabricated, you can use verb constructed, having a window through which light can fall on the junction device, on PN junction. Actually, it is the PN junction here, and it is the depletion layer. It is the depletion layer, and this is junction here, PN junction. When light falls on this, then light absorbed, and this PN junction is made of material whose energy gap between valence band and conduction band is less than the energy of light photons. PN junction, simply PN junction, electrodes. Now it is operated in reverse bias to detect the light falling on. Actually, its purpose is there to detect this light falling on this, and if the intensity of the radiation fluctuate, then reverse bias current will decrease. So now I take, so it is optical or photodiode. Photodiode is made of material whose energy gap between conduction band and valence band is less than the energy of photons of visible light. I have already told you that working of these diodes is based on photoconductivity, and photoconductivity is possible if the energy gap between valence band and conduction band of semiconductor is less than the energy of photons of light falling on it. So this is, I have shown, actually this diode is operated in reverse bias. Here, you know, when we apply reverse bias, width of division region gets increased. P junction, PN region, it is connected here negative positive. Okay. Reverse bias given. A critical value of reverse bias is given. You know, in reverse bias, current flows this way, and that current is of minus charge carrier. I hope you remember that in this N region, electrons are in majority, holes are in minority. There are holes also because of intrinsic charge carrier density. There are majority of holes and minority of electrons. There exists junction field here from N to P region. So when light is allowed to fall here, if light is not allowed to fall, a very small current will be flowing in the circuit, which is there due to minority charge carrier. If simply it is given reverse bias, then current in the circuit, the current will be of microampere order, and that current is due to minority charge carrier. I hope you remember, I have just now told that holes here are minor charge carrier. Holes are there, electrons are there as minor charge carrier because those electrons and holes are there due to intrinsic charge carrier density. Semiconductor has electrons and hole already present because of thermal agitation at room temperature. At 0 Kelvin, so there are no electron hole. But at room temperature, holes and electrons are present, and these majorly charge carrier are obtained here because of impurity added to them. So, when photodiode, when a photodiode is given a critical value of reverse bias voltage, critical value of reverse bias voltage, then a very small current flows as shown here. Here current flows in circuit, and this current, we know, this current is there because of minority charge carrier. Actually, minority holes are repelled this way, electrons are repelled this way, minority holes. Minority charge carriers. 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 Yes. So, minority charge carrier cause this reverse bias current. Now, when light is incident on PN junction, then electrons absorb energy of photon and create more electrons in conduction band, and holes in valence band. These electron hole pair are created in depletion layer. These electrons and holes are created in depletion layer or depletion region, I should say, depletion region. The junction electric field. The junction electric field drifts the electrons and holes. This these electrons holes created and drifted. These electrons and holes due to the drift of electrons and holes increases the reverse bias current. By electron hole pair are created which are separated by junction field drifted this way, or you can say here that these electron hole pair before they recombine are drifted and reverse bias current increases. The intensity the increase in reverse bias current increases with the increase of intensity of light falling on junction. The word intensity is not clear to majority of students. Intensity means more energy fall here, and more energy means more photon. Actually, in terms of photon picture, intensity of light defined as the number of photons falling per unit area per unit time. Larger number of photons, larger the energy. So that number, big number of photons falling on this create large number of electron hole, and that way current reverse bias current increases. Reverse bias current increases. Now I term this as photodetector. In fact, this diode has very wide application in optical communication. In communication, telephone communication, our sound is converted to electrical signal. Those electrical signals are given to, there is one device here, I will tell you, LED, and that fluctuating current produce fluctuating light. That fluctuating light is incident here, which produce a fluctuating current. that fluctuating current is given to the devices and reconstructed into the form of voice again. So main use of this is to detect the signal falling on it. The signal falling on it here create electron hole pair, and generally I have told you many times, wave means something is varying. Our sound create longitudinal wave, longitudinal change, wave which create variation of pressure, and that pressure variation is converted to electrical signal which create again light, and those fluctuating light fall here which are detected by this. So you can read further book. Now if you plot the graph, current and V. So it was the reverse bias current for critical value, but when light falls, this reverse bias current may increase like this. It may increase. Like this. Here I suppose 0, I1, I2. As intensity increases, reverse bias current increases. So remove sorry. Like this. So you can read the book for this purpose, and this diode basically used for photodetector. So photodiode acts actually on the principle of photoconductivity. Thank you. Please like the video, share the video, and ask your friend please to subscribe the channel. It will help the society, not me. Actually, the quality education need a lot of knowledge, and knowledge can be obtained by studying the books and listening the people who know the topic. Thank you.